So we'll start talking about the 5 W's and the how. So we'll be starting with the what. Basically, hydraulic fracturing is injecting mixed fluids deep underground to extract natural gases like methane using high pressure. Millions of gallons of fluids are used and is mostly comprised of water, proppants like sand, and chemicals that are toxic and non-toxic. Now the when. The first form of fracking was back in 1908, and the first form of natural gas fracking was in 1940. It wasn't until 2003 that it was used widely on a massive scale after hydraulic fracking was exempted from the EPA water drinking regulation. Dub is where. Hydraulic fracturing takes place globally, but mostly in the US, South America, and parts of Europe. In 2008, approximately 60% of new oil gas wells worldwide use fracking, and it's estimated that 80% of future wells will require hydraulic fracking. Who is involved in fracking, you might ask? Well, they are oil companies, natural gas companies, and drilling companies that include, but are not limited to, Southwestern Energy Company, Devon Energy Corporation, Exxon, Range Resources, and Apache Corporation. So why do we do it? Well, we produce more oil and gas so we don't have to rely on foreign energy sources. By doing this, we'll have more jobs, as well as produce clean burning natural gases. Currently, gases produced from fracking generates a fifth of our nation's electricity and emit fewer greenhouse gases than other fossil fuels. And here's a diagram of how hydraulic fracturing generally works. Before any drilling can be done, proper infrastructure must be in place for the drilling rig as shown at the top. When the vertical part of the well is drilled, which can go to a depth of about 12,000 feet or more, multiple layers of cement and steel is used to create an impermeable layer between the well and the ground, and continues to go down vertically until it is near the area where natural gases are located, also called the shale zone, and then horizontal drilling begins. The fluids are excreted at high pressure through the perforating device that is inserted into the horizontal part of the well that would create little fractures into the shale zone. Gases are released through these fractures and travel from the horizontal part of the wellbore to the surface to be collected and used. In addition to this, the studies are currently being done that could link hydraulic fracturing to inducing seismic or earthquake activity, but research is still inconclusive. Moving on to environmental impacts. In the hydrosphere, water pollution can occur underground because studies have shown that anywhere from 20 to 85% of fracking fluids stay underground, along with the toxic chemicals used within the fluids. In addition, up to 8 million gallons of water can be used at one time per well. In the biosphere/anthroposphere, hydraulic fracking and drilling can cause dust formation that may cause respiratory conditions, and the large amount of noise pollution can also affect wildlife habitats or residential areas for people like us. In addition, well contamination can occur that may also seep into wild or agricultural systems. For the atmosphere, there's a chance that uncaptured gas can flow into the air and migrate away from the drill site into other areas and cause some harm. The diesel pumps that are used to pump fracking fluids deep underground at high pressures can also cause local air pollution. As for the geosphere, it was mentioned before that seismic activities may be linked to hydraulic fracking, and there are patterns found by researchers that illustrate seismic activities in areas of high fracking use in states like Kansas, Oklahoma, and Ohio, where there were barely any seismic activity before the boom of the fracking industry. But at any rate, many scientific researchers are thoroughly investigating the conclusion of the theory. I hope you enjoyed our presentation. Thanks for watching.